Good morning once again, and I'm switching to the next topic of surface chemistry. This is preparation of colloid. So, preparation of colloid, actually, there are total three methods. One is a chemical method, another one is electrical disintegration method. This is also we study under Briggs arc method, and third one is peptidization. Okay, so in notes this condensation method is written. Actually, this is Briggs arc method. In detail, you will study in coming slide. So first one is chemical method. So in this oxidation, reduction, or hydrolysis of colloids, okay, takes place, and after this the colloids are formed. So first I am taking the example of oxidation. Okay, the oxidation process, this is hydrogen sulfide gas is this, and this is bubbled through the sol means colloid. Sol full form is solid in liquid. I have already told you. Solid is the dispersed phase and liquid is the dispersion medium. So sol is a like short name of colloid. Okay, so H2S gas is bubbled through the sol of oxidizing agents like bromine or SO2. Okay, so when this gas is passed, then hydrogen bromide gets separated and sulfur colloids are formed. Okay, and sulfur colloidal solution of sulfur is also multimolecular form of colloid. In last lecture we have studied this. Second is by reduction method. So colloidal solution of gold, this is gold chloride. Okay, so this AgCl3, so its reduction is done by tin chloride. Okay, now it leads to formation of tin tetrachloride, and gold, colloidal solution of gold is formed in this process. So these examples are very important for you to remember, because the question is asked from this section. Another is by exchange of solvent. Okay, so this is also one of the method in which true solution of substance is added to a solvent in which substance is less soluble. For example, colloidal solution of sulfur can be prepared by this method. Another is excessive cooling. Okay, colloidal solution of ice can be prepared by intense cooling of water in solvent such as chloroform or ether. If non-polar solvent, in non-polar solvent, few water molecules aggregate to form the colloidal size particles. But these points I have taken from a reference book. The main method will be number 1 chemical method, and number 2 is electrical dispersion or Briggs arc method, and third one is peptidization. Okay, so these, as per NCERT, only these 3 points are mentioned in NCERT. So I am directly coming to the Briggs arc method. It is a very like easy for you to remember if you remember it through diagram. You see, there is there are two buckets. Okay, in the outer bucket or container the ice is present, and in inner container certain solvent is present. Okay, so now the substance whose colloidal solution, that metal whose colloidal solution you are supposed to prepare, that is taken as electrode. Okay, normally this Briggs arc method is used to form gold sol. So the electrode of this gold is taken, and very high voltage is supplied, and the voltage is so high that this metal gets directly evaporates. Okay, so as soon as the vapors of the metal is formed, it immediately condensed because of the presence of this cold solvent or cold liquid present in this. This is cold because of the ice present outside the container. Okay, so those vapor of the metal immediately condense to form particles of colloidal range, and your colloidal solution of that metal is formed. Okay, and to stabilize the colloidal solution, we add a little bit of alkali. Okay, so this is a Bredig arc method. So third one is the peptidization method. In this this is very important, peptidization, because peptidization is a reverse of coagulation. Okay, coagulation and peptidization, they run parallel. Peptidization means conversion of precipitate into colloidal state, and colloid means peptidization means conversion of precipitate into colloidal state, and coagulation or precipitation or flocculation, these three terms are common thing. So this precipitation means conversion of colloid into precipitate. Okay, so both are reversible. So in peptidization we convert a precipitate into colloidal solution. How we do this? By adding suitable electrolyte and excess of dispersion medium. I am writing here EXDM, don't forget this. Okay, excess of dispersion medium, this is missing in the notes. So freshly prepared precipitate preferentially absorbs the electrolyte ion to form the charged species. Now you need to understand this thing. You see, this is ferric hydroxide and this is the ferric ion which is coming from electrolyte. Now if I say that electrolyte is this ferric chloride, it is a salt, na? So salt are electrolytes. So in the solution ferric chloride will give ferric ions, and the ferric hydroxide's precipitate is formed. Now you are adding the electrolyte, this Fe3 plus ion coming from the electrolyte, it is added, but here in between this DM, dispersion medium, is also there, and in the presence of dispersion medium little bit of electrolyte convert this precipitate into colloidal state. Now how this precipitate is changing into colloidal state is very interesting phenomenon to understand. Around this ferric hydroxide colloid, these ferric ions get surrounded. So mean to say this is the ferric hydroxide, particles of the ferric hydroxide, and all the side it gets surrounded by ferric ions. Okay, so what type of colloid will be formed? Positive sol, na? It is a positive colloid, na? Positively charged colloid, na? So similarly, many positive charged colloidal particle it suspend in the dispersion medium, and you know that charges repel each other. Okay, so this is what is written here. Okay, the freshly prepared precipitate absorb the electrolyte ion to the charged species which repel each other. So that is why these dispersed phase particle of the colloidal solution, they do not come closer to each other, they repel each other, and in this way they get suspended in the dispersion medium and remain in the colloidal state. Suppose this similar charge is not there, then what will happen? These colloidal particle will come closer to each other and will get settled down, and then precipitation will occur. So peptidization is conversion of precipitate into colloidal form, and coagulation is conversion of colloid into precipitation state. Okay, so these are both interconvertible, and in both the process electrolyte is added. In peptidization, little electrolyte and excess of dispersion medium is used, and in case of precipitation or coagulation, you have to add excess of electrolyte. Okay, not only excess, little bit electrolyte is also sufficient, but dispersion medium here it is not added. But in peptidization, along with electrolyte, you have to add excess of dispersion medium also. I hope you got. So I'm switching to the next topic, and this I will discuss in next video. Thank you.